take a look at one more converging lens problem in this episode. So the problem we're going to look at a convex lens has a focal length of 4 centimeters. A 1.5 centimeter tall object is placed at 3 centimeters from the lens. Okay, we want to calculate the distance, the height, the orientation of the image. All right, as always, it's recommended that you first start with a ray diagram, and that's really what I want to cover right now. All right, remember, all the rules still apply, so you can draw your principal, okay, or rather the ray that is parallel to the principal axis, and that will go through the lens and through the focal point, if I'm allowed to draw it, through the lens and through that focal point. That's ray 1. And the second ray, I'll draw that goes right through the center of the lens just because it's easy. Now you'll notice right away that I am incapable of drawing this, but you'll notice right away that these two rays are diverging. And when that happens, what you have to do is we have to use those ray extensions, okay, to see where the image is formed. When this happens, that means we're going to get a virtual image, right? The image is not going to form on the side of the optic that we expected. It's going to form somewhere on this side of the optic, and that's the whole point of the ray extension. And so we have one ray extension there, and then we'll draw on our second ray extension over here. Just get our ruler lined up. Ruler is just not behaving. All right, and we want to find the intersection point, so we'll line these up. And there we go, that's our two extensions. So our actual image will be formed somewhere over here. And now you'll notice something. First, the image is a virtual image. It's on the same side as the object, which is not what we want when dealing with lenses. Or not necessarily what we want, but it implies that it's virtual. It's also enlarged, right? So you're looking at like a magnifying glass, essentially. Okay, it's what your eyes, if your eyes were over here, you would see that enlarged image. So we can take a look at this mathematically. 1 over f is going to be 1 over the image distance plus 1 over the object distance. And we're going to expect the image distance to be negative. And so our focal length is 4 centimeters. Right, that's positive because it's on the same size. Our image distance and our object distance, right, is 3 centimeters. Okay, again, it's on this side. That's going to be positive. So if we subtract these, and you look at your answer, okay, the answer works out to be negative 12 centimeters. All right, the negative implying that it's on the same side as our object and further away from the lens. So we can go ahead and look at the magnification as well and figure out that image height. And so our initial distance, right, or our image distance rather, is 12 centimeters. All right, subscripts, important role. All right, and our object distance was 3 centimeters. Our height is what we're looking for, and our object height is the 1.5. And you can go ahead and solve for that object height. We should see that the object is 6 centimeters in height now, or 4 times as large. All right, and the orientation is upright, virtual, and enlarged. All right, that's all there is to this one.